Hello, this is Pete Cachope. I'm Chief Scientist at Opalytics, and I'll be presenting a short video today using instant apps on the Opalytics Cloud Platform. So the video today will demonstrate the standard diet example. Here we are. I have logged into the Instant Apps portal for the Opalytics Cloud Platform. I just logged in with the standard browser. I just logged in with using Google Chrome. And this is the entry page. So the very first thing I need to do is create the diet instant app. So before that, let me show you the example that I'm working off of. So this is GitHub Opalytics ticdat is a public repository. If you browse here to examples and diet, this is the diet.py engine that I'll be uploading, and this script creates the Excel file that I'll be uploading. So let's look at this code really quickly. I'll refer back to it a little bit later. So I've written a lot, and I think the public examples are pretty good explaining the functionality of ticdat and why we developed it. We've received good feedback on that. So just really quickly, the input schema for diet, the 3 tables. Each table is organized into primary key fields, primary key field or more than one primary key field, and a single data field or more than one data field for each table. Here we're defining the foreign keys between tables. This is optional, but it's very useful. Here we're defining the data types of the different data fields. Again, optional but useful. And here we're doing the most sophisticated thing that ticdat supports, which is adding a data row predicate. So the use here is that we want to make sure that the max nutrition is always greater than or equal to the min nutrition for the categories table. Okay, now let's upload that as an instant app. Here is the instant app section in the Opalytics Cloud Platform. You go down to instant app. We'll call it diet. It's going to be a Gurobi app because our standard examples are Gurobi. Let's select a nice image because that makes everything cleaner. So this JPEG isn't on the GitHub, but you don't really need the JPEG. It just makes it easier to sort your apps. And then let's upload the diet.py file. This is our main file. Instant Apps also supports multiple files if you want to organize your app into subsections. But now that we've uploaded the file, when viewing it, it also creates it. So you can see it knows the schemas, knows the input, knows what input tables, knows what output tables. It actually knows some pretty good details about the tables. You can see it knows where the primary keys are, it knows some things about what's expected for each of the data types. Okay, let's and use that. So we're going to need to make a new project for the diet. So let's do that. Now let's upload an XLS file, an Excel file. And sometimes the upload is a little silly. And right here, diet sample diet XLS. This is the file that's created when you run create XLS file.py. And again, it was easy to find which instant app I want to use because the little icon and the name made it very easy to find. Now I'm importing it. And of course, the thing everybody wants to do right away is just solve it. So let's do that. And you can see the solution reports are organized nicely because there's a parameters table right down here in solution schema. There's a parameters table of the expected schema. So the Opalytics Cloud Platform GUI formats that as the KPIs table. And then the tables that show how to buy food and consume nutrition are similarly well organized. You note that we cleaned up the names a little bit. When you're using ticdat, the table names are underscore delimited, and they're all lowercase. That's because the table names are used as attributes when programming. But the GUI is smart enough to know that it's easier to read them when you have uppercase, lowercase, and use actual spaces. there's some similar magic when you're reading and writing Excel files as well. So again, what is the food we're supposed to buy? This is our beloved hamburger, ice cream, and milk diet. Who doesn't want to live on a diet like that? Now let's delete this solution because its presence might be a little distracting. And let's show off how the schema is integrated into the GUI, right? So we already can tell a little bit how the schema is integrated with the GUI because it uploads these tables. So now what happens if I define the fat data twice? So you notice when I added this fat record, a bunch of things happen. In respect to the defaults of 0 and infinity, the default only default I needed to override was for max nutrition to make it infinity. And then, of course, because I defined fat twice, I get an error saying that I have duplicate primary keys. So the GUI has a nice undo. So I can get rid of that. So that's one type of data integrity. It respects duplicates, respects foreign keys. The only foreign keys are in the nutrition table. So if instead of salad, I instead say greens, foreign key failure. Okay, so it shows up nicely in red there. Undo. Oops, there it is. See what else can I show? So you have to have numerical data here, right? So I can't say 8. That doesn't work. It's got to be numerical. The numerical data has to obey rule. See, infinity is not allowed for this column as defined in the data types, so it won't allow it there. Okay, let's show the most sophisticated one, which is in categories. So you see how sometimes infinity is allowed here. So again, you can't allow infinity. No infinity in the min column, because again, that's the way the data type was set up. But infinity is allowed in the max column. Let's do the most sophisticated check with that predicate. Let's say have min nutrition greater than max nutrition. So this one, as things are currently implemented, this one is too sophisticated to be part of fast fail, although we're going to loop around and implement it as part of fast fail at some point. So for now, you won't get anything funny showing up in this table, but you still do get the data check occurring through the GUI. And it happens when I run the solver with that min greater than max record. It did successfully solve it, but it removed that row, and it showed, and instead it reported that row here in the issues column, in the issues section, right? So it says the predicate check failed, and it tells you, gives you a list of lists that tell you which rows failed. So going forward, we're going to make this even more sophisticated, but for now, this is functional. You're getting that data in check integrated into the GUI. So as long as you obey good protocol, check your issues, you'll know when that sort of bad data occurred. Okay, so thanks for your attention, and we'd appreciate any feedback.